In this video, we're going to apply L'Hopital's rule to find the limit of an indeterminate form produced by a difference. It says evaluate the following limit using L'Hopital's rule. And they give you the limit as x approaches 0 from the right for negative 10 over x plus 2 over sine 5x. So if I plug in something coming from the right of 0, that'd be a really small number. If I take 10 divided by a small number, I get negative infinity there. So I have negative infinity. And then if I plug in something coming from the right that's close to 0, so sine at 0 is going to produce a really small number, or close to 0 will produce a really small number. So I'm going to get negative infinity plus infinity here. So I've got myself an indeterminate piece here. So I need to use L'Hopital's rule, and to use L'Hopital's rule, I'm going to actually add these together with a common denominator. So I'm going to say limit as x approaches 0 from the right, and then I'm going to multiply this fraction by sine 5x, so I get negative 10 sine 5x over x sine 5x. And then I'm going to also multiply this side by x, so I'm going to say 2x over x sine 5x. And then I'm going to combine these together, so that would be negative 10 sine 5x plus 2x all over x sine of 5x. Now I'm going to apply L'Hopital's rule by saying the limit as x approaches 0 from the right, and I'm going to take the derivative of the numerator, so that's negative 10 sine 5x plus 2x, and then I'm going to take the derivative of the denominator separately. And when I take the derivative of the numerator, derivative of sine would be cosine, so I end up with negative, I'm going to write the limit again. So I get negative 10 cosine 5x times the derivative of 5x, and derivative of 2x is 2, so I get plus 2, divided by, I have to use the product rule here, so we're going to say x is equal to, u is equal to x, u prime is 1, v is sine 5x, and v prime would be cosine 5x times the derivative of 5x. So v prime is equal to, derivative of 5x is 5, so I get 5 cosine 5x. Now I'm going to take u prime times v, so that's just sine 5x. And I'm going to add it with x times 5 cosine 5x, which would be 5x cosine of 5x. And then I need to evaluate this. Plug in 0. I get cosine 5x, cosine of 0 is 1. Oh, before I plug in 0, I need to do this derivative here. That's my bad. So let's take the derivative of 5x. So we get the limit as x approaches 0 from the right, and we would get, that's derivative of 5x is 5, so that's negative 50 cosine 5x plus 2 over sine 5x plus 5x cosine 5x. Now if I plug in 0 in the denominator, I would get 0 for sine. I'd also get 0 for this, so I have 0 on the bottom. And then if I plug 0 in here, I get cosine of 0, which would be 1 times negative 50 plus 2, I get negative 48. But I get something that's still undefined. And so what I need to do is I'm going to have to take the, let's see. Well, hold on a second. I'm evaluating this incorrectly. So I plugged in 0. That's my problem. I plugged in 0 instead of plugging in 0 in from the right. So what I want to do is plug in 0 from the right. So this is basically like cosine of 0, or cosine of a really small number. It's going to give you negative 48 on the top. But on the bottom, when I plug in 0 from the right, sine of 0 will basically be 0, but this will not be 0. This will be a really small number, okay, a very small number. And so what ends up happening is I have negative 48 divided by a, I'm going to call this not 0, but a small number, which when I do that, I get negative infinity. So I can say that the limit as x approaches 0 from the right of my function f of x is equal to negative infinity.